Okay, so in this video we'll go ahead and finish up our treatment of planar motion of rigid bodies by taking a look at impulse and collisions. Okay, so we'll go ahead and start with Newton's second law. We'll say that F equals m times dv cm dt. Alright, so if we go ahead and integrate that, the impulse P is going to be equal to integral f dt, right? It'll be equal to m times delta v cm. So we just went ahead and recovered the impulse momentum theorem for the linear part, but we can also go take a look at the rotational part here. And just so we can keep things straight, let's say there's my axis there. My force is being applied like so. This would correspond to the line of action. Alright. Or sorry, actually that's the lever arm. The lever arm is perpendicular to the line of action. My bad. Alright, anyway, the torque is equal to I omega dot, right? So if I integrate that with respect to time, that'll be equal to I delta omega. But the torque is equal to F L dt. So I delta omega. This becomes PL, because L is a constant, equals I delta omega. Or we get that delta omega is equal to PL over the moment of inertia. Alright, this gives rise to the baseball bat theorem. The official name is center of percussion, but you'll see why it usually gets called the baseball bat theorem. The idea goes like this. Let's say we have a baseball bat here. Yeah, I know my baseball bat just looked more like a cricket paddle. Just deal with it. Let's say the center of motion is, center of mass is there. My bad. We'll have a baseball fly in and hit it here. That'll be our point O prime. It'll come in at some speed v0, mass m, and so it'll impart at an impulse p right there. Now the trick is we want to figure out where we want to hold the bat. We want to hold it right there at point O, and the idea is that we want to avoid stinging there, so we want the velocity at O to be 0. So let's call this length L, that length L, whoops, L prime. Alrighty then. So we can say that V about point O will be equal to the velocity center of mass minus omega L, how we rotate about the center of mass, right? And from the impulse momentum theorem, we can say this will be equal to P over M minus PL prime I over L. So we get that this velocity is equal to P times 1 over M minus LL prime over I. So we want to avoid stinging, so we'll set V about O to be 0. So that's going to require, the P drops out, it's irrelevant. It requires that 1 over M minus LL prime equal over I equals 0. We can write our I as mk squared as per usual. So we can cancel. And so we're left with k squared equaling L prime. So in other words, you want to hold the bat at the other center of oscillation. All right, and with that, we finally put planar motion of rigid bodies to rest. The next series of 3 lectures will be on the motion of rigid bodies in 3 dimensions.